Welcome to EDU World Space.
Region at point 1, the exit hole. So we're going to say 1 is the exit hole, and 2 would be the top surface of liquid in tank. And so we can then also apply the equation of continuity to the two same points. So we can say P sub 1 plus 1/2 rho V sub 1 squared plus rho G y sub 1 equals P sub 2 plus 1/2 rho V sub 2 squared plus rho G y sub 2. We can then say that the atmospheric pressure plus 1/2 rho V sub 1 squared minus V sub 2 squared equals the atmospheric pressure plus rho G times the change in y position, y sub 2 minus y sub 1. Of course, the atmospheric pressure then cancels out, and we have that atmospheric pressure cancels out and the density cancels out. And so we have that here, V sub 1 squared minus V sub 2 squared multiplied, this equals simply 2gh, where h is equaling y sub 2 minus y sub 1. And now we can apply the equation of continuity and say that a sub 2 squared divided by a sub 1 squared minus 1, this would all be multiplied by v sub 2 squared equals 2gh, and then simply solve for v sub 2. This is equaling the square root of 2gh divided by a sub 2 squared over a sub 1 squared minus 1. And this is equaling the square root of 2gh a sub 1 squared divided by a sub 2 squared minus a sub 1 squared. We know that because the water level is decreasing, you could say for part A, v sub 2 is equal to the change in height with the negative change in height with respect to time, because the water level is decreasing. And so we can say dh over dt is equaling negative times the negative square root of 2gh a sub 1 squared, and then again divided by a sub 2 squared minus a sub 1 squared. This would be our final answer for part A. And we can then, for part B, integrate to find the height as a function of time. And so we can say dh over radical h is going to be equaling the negative square root of 2g a sub 1 squared divided by a sub 2 squared minus a sub 1 squared, and then this would be multiplied by dt. And so when we integrate for part B, we're integrating from the initial height h naught to h of dh over radical h, and this would equal again the negative square root of 2g a sub 1 squared divided by a sub 2 squared minus a sub 1 squared times the integral from 0 to t dt. Again, because there isn't any, the t variable is not accounted in here, and so this would be treated as a constant, essentially. And so this is going to equal 2 times radical h minus radical h naught minus radical h naught, and then we can solve for h and say that h is then equaling radical h naught minus t times the square root of ga sub 1 squared divided by 2 times a sub 2 squared minus a sub 1 squared, and this entire term would be squared. So this would be our answer for part B. And then finally for part C, we're going to solve for time at h equaling 0. And so a sub 1, let's calculate this first. This would be pi times 0.25 times 10 to the negative second meters quantity squared. This is equaling 1.963 times 10 to the negative fifth meters squared. And then a sub 2 would be equaling 1.3 times 10 to the negative third meters cubed divided by 0.106 meters. And this is equaling 1.226 times 10 to the negative second meters squared. And so we're going to set radical h naught minus t times the square root of ga sub 1 squared divided by 2 times a sub 2 squared rather, my apologies, minus a sub 1 squared. We're going to set this squared equaling 0. And so solving for t, for part C, we get that t is equaling the square root of 2 times the initial height times a sub 2 squared minus a sub 1 squared. And this would be divided by g times a sub 1 squared. And now we simply have to solve. So t is equaling the square root, it's going to be quite long, 2 times 0.106 meters multiplied by 1.226 times 10 to the negative second meters squared quantity squared minus 1.963 times 10 to the negative fifth meters squared quantity squared, close parentheses. This would be divided by 9.80 meters per second squared multiplied by 1.963 times 10 to the negative fifth meters squared quantity squared. And we find that t is equaling approximately 92 seconds. This would be our final answer for part. That is the end of the solution. Thank you for watching.